Solar photovoltaic power, or solar PV, is pretty well known. It's the most common form of solar power, and the one you see on the roofs of houses. It generates electricity directly from exposure to light. It has no moving parts, so there's very little maintenance involved, aside from washing it every now and then to make sure its light source isn't obscured. Solar PV has made many great contributions to society, like powering the ISS and other space missions, and is largely responsible for the establishment of the concepts of distributed microgrids and virtual power plants. However, in terms of affordable and chemically stable options, the efficiency of photovoltaics is currently limited. Although they are consistently growing more efficient, and solar panels produced now are far superior to the panels produced even just 7 or 8 years ago, current photovoltaics tend to have an efficiency of about 20%. The efficiency problem is the focus of a lot of research labs currently, and if efficiency is increased by 10 to 15%, with the price of panels remaining similar to now, it will be a watershed moment for the uptake of renewable energy. However, there is already a solar technology with a really high efficiency of about 90%, and that is solar thermal panels. It is less talked about than solar PV, likely because it is admittedly less flexible than PV, and that is because of its method of capturing solar energy: heated water. Thermal panels consist of a winding pipe filled with water covered in a dark coating to absorb radiation from the sun and heat the water in the process. This heated water is then used as hot water for your everyday home uses like bathing or washing. So with this higher efficiency in thermal panels, there must be something the PV panels aren't capturing. Likewise, there is something in the spectrum that is converted to electricity using PV, with electricity being a much more desirable and versatile form of energy than heated water. And so the intuitive thought came: what if we just stack the two types of panels on top of each other? Hence, solar hybrid photovoltaic thermal, or solar PVT. These panels produce both the incredibly useful electrical generation of PV panels and the water heating of thermal panels. This is a very interesting combination, especially when the addition of the thermal backing has the capacity to complement the PV panel, as photovoltaics gain efficiency when it remains cool. However, what if this technology not only enabled solar-powered everyday hot water usage, but allowed for retrofit to make your hot water tank into an energy storage system? Check in for part 2, where I'll discuss an idea that uses old tech to plunge us into the future.